My name is Andrew Goldman. I'll be chairing this panel that's starting just now, and we're excited to continue our conversation about the relationship between things that we wear and technology. So we'll be continuing that thematically in this session. So our first speaker is going to be Clare King, who is the founder of Propel, which is a product innovation management company focused on the development, sales, and marketing of innovative textile-driven technologies with the U.S. military and fire service as primary customers. So we're very pleased to welcome Clare King, who will be speaking on practice, design, and innovation with textiles. Thanks, Clare.
So this conference has given me a great deal to think about. I usually am at industry conferences presenting about specific products, and this is much more holistic about how I approach the development work that we do, and I'm stepping from fashion into what one of the last questioners talked about or hinted at, which was really about the connected worker and where the technology is going to get used that isn't about necessarily fashion, but is about from craft all the way through to textiles and technology. So just to introduce a little bit about my company. We're quite small. We're only actually 5 people, and we happen to be all women, and I just say that was quite by chance. If a man applies, we're very welcome to interview you, and we'd love to hire you someday, but we never get men apply for the jobs for some reason. And what we do is we are focused on, in the textile sphere, on looking at the problem and solving backwards, but we very much use human-centered design when we have a problem. I've worked in this business for many, many years. I actually didn't train in textiles, but I've had a series of mentors over the years. And the team at Propel is heavily focused on people who are highly trained in textiles. And one of the things I've also thought about during this conference is that each of us has some passion in our home life or our hobby life that we also do. One of my young staff has a fabulous business making flower girl dresses. So she has an extra business, and she's up all night sewing these incredible flower girl dresses, and she's starting to introduce technology into that. And then she comes in the morning and she's testing steams, and she's doing all kinds of things on technical textiles. So we're very much human-centered design, which means that we tend to work from the body backwards, but even before the body, we work from the problem. So I'm going to show you a little bit just of one problem before I get into the technology work we're doing that's specific to electronics in textiles. Someone mentioned slow fashion. This is the ultimate slow fashion piece. This is a suit that we are currently prototyping. We've built 15 prototypes, or 15 duplicates of a prototype, having gone through 3 stages, and it's called a steam suit. If there is an accident in a submarine, then the sailors will, or the submariners I should say, 2 of them will don this suit, and they'll put on equipment over it, and they will go into a steam hold and try and turn off and fix whatever the problem is. If you remember that Russian sub that went down, they didn't have anything like this, and that was part of the problem. So they could close off where the problem was, but they couldn't actually go in and fix it. So the Navy came to us and said, what we're wearing, we don't have very good visibility. And I actually think I'll just show you a short video that the Navy literally sent me yesterday.
This is a protective ensemble. It's a prototype garment making the current configuration a little bit lighter. It would allow greater mobility. It would allow better vision and communications. This suit is worn on board a submarine in case of a steam leak. It would be donned in conjunction with the SCBA. The important part here is that the ensemble is going to allow the user better access to the steam leak. It's going to allow them to be more comfortable inside of the suit. It's going to give them better mobility and better mission accomplishment.
To find out more about the Naval Supply Systems Command, visit their website.
Actually has 83 hours of labor in each individual suit. We make it in a factory in the United States using all materials that are sourced in the United States, fiber forward. That is the law. We have to do that. And we actually make it in a factory where 75% of the employees are certified disabled. It is one of the most phenomenal places you'll ever go in your life in terms of being a garment factory. Very, very creative people. And we expect in a couple of years that the Navy will buy about 450 of these suits and outfit every submarine that they have with 4 of these suits. So that's the kind of problem that they give us. They wanted us to make it lighter, they wanted to make it more ergonomic, but it also got into physiology because the testing was human factors, can they work better in it, and then they tested the core body temperature to see whether what the rate of change was of the core body temperature while they're actually trying to solve a problem inside the submarine. And this was 1 degree less than the current ensemble, and if anybody here is a physiologist, they know that that's significant. So we're textile people, but we have to understand these things. What I'd like to talk about in more detail is the work we've been doing in the fire service for the last 10 years, which has actually resulted in a connected worker shirt that measures physiology. This is the average environment of a firefighter every day. It's very, very hot. It's very difficult. What you don't see here is that usually they can't see anything. They're just operating inside a building full of smoke. And what happens to firefighters is that 50% of the firefighters globally and in the US die of a heart attack or heart-related incident either on the job or within 24 hours of leaving their shift. So if we can know what condition they're in, maybe we can actually help monitor their health better. And the firefighters are all in favor of this. So this is the system that at Propel we've worked on, and I should give credit. We've worked with Worcester Polytechnic Institute, Skidmore College Exercise Physiology Department, Illinois Fire Service Institute, which is part of the University of Illinois at Champaign-Urbana, and Globe Fire Suits, and then 2 technology companies, Zephyr and TRX. So you've got a massive amount of information and technology coming together, but really what it's about is the shirt in the middle, where you're wearing something that's measuring your physiology. It's got respiration, interbeat interval of heart rate, skin temperature, activity level, position, so you can tell whether they're lying down or crawling. You can tell how often they've moved recently. And all of this has to be into something that's manufacturable and cost-effective. This was a 10-year project. If anyone's interested, I can explain the technology. I won't go into all the details of it right now. But essentially, they're outfitted, they wear it, and then on the top right-hand corner, there's a system that would be at the instant command that can then relay all the information. And it's currently, after 10 years, been sold into 5 training institutes, and gradually it'll get rolled out through the fire service. Now, our role in this was to develop the textile and to develop the design of the garment, which is now patented, and to develop the integration of the electronic systems that were supplied by the technology companies. None of which was easy, and we did a huge amount of field testing. Boston Fire Department, Oxnard Fire Department, just tons of them, all Fairfax County, where they actually wore this for extended periods of time, and we went and observed them. There's nothing like watching the user in their job, how they're actually experiencing the garment. And we took hundreds of photographs of how they were wearing it, and then ended up designing a garment that's quite complex, but has to be simple, so they put it on every day, and they cannot make any mistakes with it. And then it has to be able to go through the washer and dryer 100 times with no breakdown in the electronics. So from this project, which is now a product, and you'll find more about it under WASP on the internet. If you put Globe WASP in, you'll find all kinds of things about it. We then were engaged by the US Navy under the Small Business Innovation Research Grant Program, which is the largest pool of seed funding for new technology development available in the United States, way bigger than venture capital or any of those things. And essentially, any agency that spends more than $100 million a year on outside research has to devote 3% to working with small businesses. And the Navy engaged us because they've got a big problem with these ships. There's 6,000 people on those ships. They don't know where they are. They don't know what condition they're in. And if there's an incident, they really have a problem. They don't know who's where or what they're doing. And the other thing is they want to reduce the number of people on the ships. A ship like this, they're telling us that in 30 years there will be 60 people on the ship and not 6,000. And they can't use robots because robots can't climb ladders. And you can't build an aircraft carrier like this without ladders to get from one level to another. So they tried robots, they gave up, and they said, okay, human-ship interface. And that's what we're working on now. We are 2 years into the project. And I have to say, it's very fascinating. Unfortunately, I can't tell you very much about what we're doing yet, but I thought I would show you some of the craft techniques and the technologies that we're using to develop this. So this is really what they're saying. On the left-hand side, this is where we are now, which is really where the WASP product is in many ways. There's a strap around the center. We've managed to disguise it a lot. But really, we want to get where the actuators, the sensors, the electronics are embedded into the garment so that it is transparent to the worker. It makes no difference to them between what they're putting on for their job every day and now and then in the future. So that's a very hard problem to solve. And this is really what sums up the issues of when you take the world of textiles and you try to then blend it with the world of electronics. We found when we started talking to the electronics folks, and Google's Project Jacquard was mentioned, and I'm a little familiar because this world overlaps. A lot of that is driven by the electronics side. And the electronics engineers are fabulously smart people, and they've got great training, and they think that textiles is kind of stupid, I hate to say, very simple. It's like, of course I can make a textile. But they're dealing with hard components, and they're dealing in a language that textile engineers don't understand at all. So the first thing we had to do was create a common language between the two parts. And then we had to find people who actually would talk to us and realize that we might be able to do something with what they had, but we had to do there was constraints on what we could do with it depending on how we integrated it. So this is the integration tools that we have in the textile world. They're pretty simple, and almost all of them have been mentioned during this conference. A lot of sewing and embroidery, that's been used a lot for integrating electronic conductive yarns. You could use flexible electronics, so you're really using coatings in some ways that you're then peeling off and putting onto the textiles. You can weave, you can knit, you could print. There's a lot of talk about printed conductive inks. They're great, but they don't last very well when you put them in a washing machine. So we looked at all of this, and we went back to looking at the constraints, and then we said, well, what do we need to get? And then in our project for the Navy, we went out and surveyed the whole world, and we found that actually there were some big technology gaps. And the technology gaps are all on the textile side. We went to every single textile company in the United States that currently makes materials for the Department of Defense. Not a single one was involved in making electronic textiles. We went to the yarn companies. Not a single one that was really feasible for us to use was making them. We had people who were making coated, silverized yarns, but they're not very durable. And I have, and I would say the Navy did too. They don't want to use silver. They know that will slough off and go into our rivers and kill the fish and all the rest of it. They want something that's going to stay in the clothing and be permanent in there. So we looked at all of this, and then we also started saying, well, what kind of integration method would be best? Weaving has great potential, and I will show you a little video at the end of somebody who is approaching electronic textiles with weaving. But we're also concerned that the transition point from weaving on a hand loom, an electronic textile, to large-scale manufacturing, which is what we would have to do with a customer that's got that many people they want to outfit, we knew that we would get differences in performance. And another project we've been working on for several years is new fire-resistant textiles. And we have to put fire resistance to everything we do. And we did some 30-yard samples of different fabrics at Gaston College in North Carolina that has a great loom, and you can do 30-yard lengths. But then you take that 30-yard length and you make 3,000 yards, and your test data, when you test it for a tear or tensile, or et cetera, will not be the same. So it's very difficult when you're innovating if you haven't got tools that take you directly from the first prototype to production with no gaps. And it's time consuming. So what about 2 years ago, I went to a technical textiles trade show, and the biggest one is coming up in Frankfurt next month, which is like my busman's holiday. It's 4 days of everything you can possibly imagine. And it's all the way from natural fibers all the way through to new technologies. It's in Frankfurt, Germany. But at this one, I was somewhere in the US, I can't remember where, and I was watching this knitting machine. And this is now my office. So this was in a trade show booth 2 years ago. This is now our knitting lab. And there was a gentleman standing there, late 60s, early 70s, and he came up to me, and sure enough, He was from Nottingham, and he came out of the Nottingham lace industry. And he's been working for this Japanese company, Shimaseki, for the last 30 years, was their first employee, I think, or second employee in the States. And so he's taken his tremendous knowledge, which is immense, from lace making, including his grandmother that handmade lace, and he's working with this company that developed an extraordinary set of tools where we can prototype at the unit of one, but we know whatever we do on that machine, we can then do by the thousands, because you just replicate the machine, or they build you a bigger machine that can do more of them at once. This machine also has a history in knitting that goes back to what you can do on 2 sticks. You know, whether it was originally quills or bamboo or now knitting needles, of course, you know, made from stainless steel, and the best ones come out of Germany, stainless steel knitting needles. And I saw this, and I looked at the software program, which I don't have turned on the left-hand side, but they have this tremendous software program. And I looked at it and I said, it's hand knitting. It's Japanese hand knitting. Now, the Japanese have a wonderful symbolic system for hand knitting patterns, very different from what developed in the West, where they were written out in a language, like, you know, where words represented the knit stitch. In Japan, it's all symbolic, and it's all binary. And so what this company, Shima, which is a very small family-owned company, I mean small by American textile or other textile company standards, did was they took hand knitting, translated it into a program, and then that allowed them to also develop these machines. And they did take from some machines that were developed in Switzerland for some of the ideas as well. And so I can think of a hand knit pattern. And okay, so I want to create a sensor that has these different properties, and I can then construct it in my mind and go in the way I would do for a hand knitting pattern, and then I can go to the machine and I can design it, and then I can knit it off. And I can do that in a couple of hours. So I'm going to show you, now one of the things is, I should just point out here and here, if anyone can tell me which one was knit and which one came off the software, at 10 feet, you can't tell the difference. So I can render exactly what's going to come off the machine, and very complex patterns. We didn't actually do this one. Shima did this one. But some of the things we're doing is we are making complex electronic shapes and sensors into these fabrics, and we can render it and render tons and tons of them, and then we can figure out whether it's going to work before we even knit it down. So this is an example of some of the things I can show you. And this is where to go back to our learning in physiology that we've picked up over the last decade. So a company that we've worked a lot with over the years, who is an OEM for just about every brand in the outdoor industry for gloves. They design and make every glove under REI's brand, if you're familiar with that outdoor company, for example. I've developed materials for them for the last 25 years, and they actually are making the gloves for the steam suit, because when I said I don't want to do the gloves, that's a very specialized world, so we brought them in for that. So we looked at the physiology of the hand, because they said to us, every heated glove that's come to market has failed. And they failed electronically, or they failed because they're too hot. So we looked at the physiology of the hand first, and we said, well, why are you putting the heater here or here? Let's put it here, so that we've got the heating yarn going around here. That heats your hand beautifully, and it reduces the amount of power you need. So you don't need 4 AAA batteries. You might need 1, so you can make a much smaller unit. So we've developed this, but as we were developing this, we also came across another big technology gap, which is the yarns available. And I've come to believe very strongly that it's the electronic yarns, the lack of good supply and innovative yarns that has held back the smart textiles. So in our Navy project, that's what we're putting a lot of effort into, is building new yarns. And we went to the largest yarn maker in the world, who we've done other projects with, and they have their innovation center in North Carolina, but they were originally a British company. And they said, oh, thank God, somebody has come to us that's got a project to do, because they think that smart textiles should exist, but they don't understand what they need to make. So we're in our second round of prototypes with them, and we think that we're going to have something that could be truly transformative. So actually, I should show you this slide as well. So when we were doing the glove, we prototyped a lot. So we prototyped just single fingers instead of having to knit the whole glove. That's in the top left and the top two left sides. There's an example of where we're testing the glove, and there's different yarns, commercial yarns we're using. And there's actually a snapshot of part of the computer program that we wrote to drive to put the yarns in the right place and to distribute the technology correctly. So, so where's this all going? It means that, you know, from our point of view, we can innovate, and I've heard a lot about that word. We're being creative with very traditional technology of hand knitting, and then we're bringing that forward using this rapid prototyping capability. And then we're able to deliver more quickly, and then whatever we deliver, we can also produce in large numbers eventually. We don't intend to be the manufacturer. We'll probably license the technology. And recently, a very large company engaged with us, having heard, we made a presentation in a conference in Europe last year, and we're just about to sign a relationship with them. So we're actually moving for the first time out of the DoD and fire service world into the commercial world with these opportunities as well. It's all very risky, and that's why the SBIR money from the Department of Defense is so helpful, because it's meant for very high-risk projects that would never get funded by industry. And for us in the company, it means that we can retain 100% ownership within the company, which means that we can continue to guide it slowly and not to have to rush into something that just because we need the money to keep going. So we've grown organically, very slowly. After 10 years, we're still only 5 people. By American, US standards, we might be considered, not successful enough. But I think all of us really enjoy what we're doing, and we have a reasonable lifestyle about it as well. So I wanted to highlight some of the other things that are going on in industry that are kind of related in a way. Because what I'm seeing is this company, Shimaseki, which makes the knitting machines, they're in a small town in Japan. Another project we're doing for the Navy, which is much further along, we're actually field testing garments right now, and they're going well, is to take needle and thread out of sewing, which you can do for some things. You'll never get rid of it for a lot of things. And we're using technology from a company called Queenlight. And I was meeting with the Queenlight people a few months ago, and I said, I just bought a Shima machine. And they said, Mr. Shima, we know him so well. And the two families are in the same town, and they use the same metal production to make their machines. So they're very, this city has lots of different people working in different parts of the textile industry, inventing new equipment. So what we're buying from Queenlight is ultrasonic welding equipment. So we're using ultrasonic sound waves to weld fabrics together. So I'm seeing this happen, and it's coming from outside the textile industry. Shima originally wasn't a textile equipment company. Queenlight does all kinds of other equipment, and the textile part is just a small thing. And the disruption to the textile industry is happening because the large textile companies and the large textile equipment companies can't move off their view that everything has to be large scale. They can't move off their view of making 10,000 yards at a time of all the same thing. And that's not the way my business in the Department of Defense is going. They're starting to think on units of 1. And one of the things they were most excited about when I told them we were going to use the Shima is that our waste from beginning to end is 3%. That's from the actual buying the fiber all the way through to delivering the finished item. Typically, making a piece of clothing, if you add up all the waste along the way, you're talking about 30%. So 30% of what goes into that dress or whatever you're wearing today actually went into the trash can first. And most of that does not get recycled. So the Department of Defense actually is starting to show glimmers of sustainability initiatives. The Navy is trying to use something called the Higgs Index. I don't know if anyone here is familiar with that, to measure all of their new developments. And so I'm pretty excited about that. And I'm very excited about the disruption that's going to happen to my business or to the textile industry, because I think it needs it. Kniterate is a Kickstarter. I think their price point is too high. They want $7,500 for this knitting machine, which is really sort of like built on the old Brother hand knitting machines that you could buy in the 80s, which you can still buy on eBay quite well. So their idea is that you will sit and knit your own sweaters in the future. And I think it's clever what they've done. Wovens is very interesting because they are two women, both of whom went to the Rhode Island School of Design. They're now out in Silicon Valley. And they have taken the Jacquard machine. I suspect they're using an AVL loom that's made in Chico, California. And they've developed a new computer program to drive it, which means they can aggregate with an algorithm all of their customer orders and then weave them at a unit of 1 yard for $48. So you could design on their system your own pattern, send them that, and they'll send you a yard of fabric back for $48, which is pretty phenomenal. And they're in business, and it's working. And then the last one is out of Israel, and I could have put lots of up, but I thought these were relevant. And this is twine, and what they've come up with is a way of dyeing waterlessly a polyester yarn, and they're moving into other yarns as well. So you design the fish on your computer screen, and then it sends a program to the dyeing equipment, and it dyes the sections of the yarn for the embroidery machine. So again, it's reducing waste. You don't have to have lots and lots of different colors, and you can get your design exactly the way you want. And I saw this, and I said, I can use this to apply different chemistries. So on our yarns, on our electronic yarns, we need certain areas that have got certain properties and certain areas that don't. Well, how am I going to know, once I've put those properties into a yarn, where I am? But if I can color them and get the chemistry in at the same time, so then you can do it. So all of these kinds of thought processes are really affecting our industry, but what they also are doing are allowing us to produce at the unit of 1, which is really exciting for my segment anyway. So I don't know if I've got any more time. Am I done? Okay, so I won't show the last video. We maybe show it later. Okay.
Great, thank you very much, Claire. Our respondent will be Paul Sajda, who is Professor of Biomedical Engineering, Electrical Engineering, and Radiology at Columbia University. He's also Director of the Laboratory for Intelligent Imaging and Neurocomputing. He'll be continuing the conversation of wearable interfaces and brain-computer interfaces. So please welcome Paul Sajda.
Thank you very much. It's really a pleasure to be here. When I was first asked to be involved with this symposium, I was a little surprised because what I do has really nothing to do with fashion. You'll see some of the get-ups that we use to instrument people, and you'll say that clearly they're far from fashionable. But I had a chance to talk with Claire yesterday, and it was really enlightening. I think that part of the point she's made about how we can think about measuring things like physiology within our clothes, within our accessories, is really starting to enable changes in how we interface with machines. And in fact, part of what my interest and research program is about is really looking at this evolution of the human-machine interface. And more or less, we're still at the stage right now with interactions with machines that use our traditional senses, our eyes, our ears, and also our actuators, our hands, our motor system. And clearly over time, this is going to adapt and change. And there are going to be machines that adapt, that we effectively program by using our physiology. And I think that ultimately the way that will be done is through that physiology being opportunistically sensed from being on our bodies from what we wear. So as Claire already talked about and showed, technology is already being integrated into what we wear, our accessories, our smart watches, etc. And talking to her yesterday, I think what I, myself, as a technologist, really haven't appreciated enough is the fact that as we try to get that technology integrated in a way where it's essentially seamless in our clothes, in what we wear, that's a huge technical challenge itself. Issues from, how do we get these conductive materials that are comfortable, that we can put transducers in that are robust and can handle wear and tear? How do we calibrate a shirt that we put on that might be sensing different modalities? Clearly, we're on the path from at least the technology side to start understanding what we might want to sense. So whether we're looking at applications and new ways to monitor our health, to making productivity kind of better for the average worker, there's the technology there, but then the gap, I think, is the actual practical application and how we embed that in a way that allows us to really be able to opportunistically sense this information in reasonable and reliable ways. So I wanted to talk about two different kind of elements of how technology is being used and kind of integrated to sense physiology, some of the types of physiology that have already been discussed, as well as physiology in the brain. So my background is in neural engineering. Part of what I'm interested in sensing are signals related to cognition and perception. But this is an example I wanted to mention first, because this actually comes from the lab of David Eagleman at Stanford. And he wanted to look at a way to create a new type of sensory input to the human. So the idea was, and the first kind of potential application was somebody who was deaf. So imagine I have a transducer, like a speaker. I could digitize that information, and I could put on a piece of clothing that had essentially tactile or haptic transducers that created a particular pattern, essentially kind of like Braille, right? But now instead of having to use that pattern by decoding it from, let's say, my fingertips, I can actually decode it from my back. Why would you do that? Well, it turns out there's a tremendous amount of your brain that is dedicated to your back, and you have good discriminability between different points on your back. So you can, in effect, really somewhat wear this in somewhat of a covert type fashion. Nobody really knows that whether you're deaf or not, and use this information to start to create an interface between a person that, let's say, is communicating with you and yourself. Now, it turns out he's been testing this not just for people that might say have a loss in a particular sensory modality like hearing, but also people that have otherwise normal sensory input as an augmentation to their sensations. And you might think that that's a bit crazy. Wouldn't it be awkward to feel all of this kind of pattern of tingling across your back to get just another input channel into your brain? Well, his studies, he's a neuroscientist, have shown that it's amazing how fast individuals will adapt and use that information if it's valuable. So he's tried this on particularly people that have to deal with information on a very short time scale. Stock traders, people that are analysts in the government. And they adapt, their brains adapt, and they take that input in and use it in a very efficient way. Now, as I mentioned, another kind of way in which or neuroscience in general is looking at kind of measuring physiology is through a concept called neural lace. So if anybody out there is, you watch the popular media, you might have heard that Elon Musk recently said he's creating this company with brain-computer interfaces, and he's been talking about this concept of neural lace for a while. It's very early stages of this, but there have been some work in the world of animal models where essentially what the idea is to weave a set of electronics. And this is actually a grid, a woven net of integrated electronics that could be injected into the brain. So you would only have to put a little bore in the skull, no major brain surgery. And that as this net goes into the brain, it essentially unravels and wraps around the brain and records across millions of neurons the underlying activity, the neurophysiology. The idea is that type of interface someday, probably a long time from now, will be part of what we wear, what is part of us that is going to kind of modulate interfaces with machines. Now, I still think that that's a bit of science fiction, but I myself am interested in this concept of how we can use physiology, including neurophysiology, to start understanding how we can sense our own cognitive state, our perception, our cognition, and modulate interaction with machines. And so we use, instead of something invasive that you inject in somebody's brain, we use something called electroencephalography. So this is a cap here. Actually, it's Andrew wearing that, where there are these sensors on the head. And so this is all in a stretchable cap. So just going back to something Claire mentioned, so let's say we put on this cap right now. Well, it takes at least one research technician to put the cap on. Is it comfortable? Then one has to make sure all of the signals we get are in fact reliable. Is the connection to the skin good? And then there's a calibration step. So that's at least a 1 or 2 person problem. In the real world, when we think about if this is ever going to be practical, we need to be able to put this thing on and not think about it, right? Assuming anybody would be willing to wear this kind of cap as a fashion statement. But so nonetheless, this is kind of proof of principle. And in addition to looking at what's happening in the brain, we're interested in looking what's happening in terms of people's eyes, their state of arousal by looking at their pupil size, as well as measuring these other types of physiological signals that Claire mentioned, but really using bulky electronics. And ultimately, the goal would be that this all goes into some type of very wearable system, whether it's for the military or ultimately into the consumer, because if we all believe kind of what's out there, this whole Internet of Things, IoT, the connected world, part of that is really only going to be enabled when those sensors are integrated right into what we wear. Now, what I want to also mention, and seems like the Department of Defense loves this kind of stuff. So we also were funded by the Department of Defense, by DARPA. And so they have this interesting problem that they wanted us to consider. And the problem was that these pilots that fly these planes, sometimes they have what's called a pilot-induced oscillation. It doesn't matter how the plane is set up, if it's the most expensive plane in the world, and it has to do with the coupling between the human and the machine. And so what happens is, as the pilot is, let's say, approaching a critical boundary, so that could be a boundary like they're landing, or they have a certain stall speed. The point is that it's a critical boundary. It means if they pass that boundary, they're essentially potentially dead, okay? In that case, if they get close to these boundaries, what they do is they overcompensate and switch their mode of cognition into one which takes in information from the world and adjusts precisely to kind of a flight or fight mode. So what they do is they kind of, in this case here, I don't know if you can see it yet, but there are these bounding boxes that we're simulating as a boundary of interest. And if this task becomes more and more difficult, they get stressed, their arousal goes up, their cognitive flexibility goes down, they start to pull back and forth so fast so that essentially they miss these boundaries, right? And it's pretty clear what's going on in terms of what's happening in their brain and the physiology. Their arousal's going up, their cognitive flexibility is going down, and we can kind of, from these different measurements, get an estimate of that state and communicate that state to the plane so that the plane adjusts its characteristics and improves performance. And this is just obviously a simulation or a virtual environment simulation where what's happening here is the individual is doing this task. That bar on the right, which is green now but will go up to red, is integrating all of this physiological information using some machine learning and estimating a state and feeding that back to the control system of the plane. And so this type of idea of how physiology is going to inform machines is kind of starting to be done in very niche areas like the military, but also actually going on right now in areas like autonomous vehicles and personalized drive. it's also very much in play. And so, one of the issues with autonomous vehicles that car makers are finding is the fact that there's this trust gap, right? So in some sense, who here is going to be willing to get in an Uber, even if it's free, if there's nobody driving the car, right? So how does the machine and the human, how does a trust bond get formed with the human? So one idea that many car makers are looking at is basically measuring physiology, trying to give the car some sense of an emotional intelligence that it can use to infer the state of the individual and then adjust the ride accordingly. And this is essentially a huge issue for all of Detroit, for Silicon Valley, and it's a system which right now is looking at the sensors being built into the car. So there could be cameras in the seat, there's going to be physiological sensing, but in the long term, it's going to be, you're already going to be essentially have the sensors on you. You're going to be able to then communicate that information directly from what you're wearing to the vehicle. So, I think in the long term, and this is a little bit science fiction, but quite honestly, a lot of this technology is developing in a way where it's going to be, real world if we can figure out how to solve this integration problem. Another thing that kind of I thought of while listening to Claire's talk and thinking about what I wanted to say is, it's interesting. I don't know if in the world of fashion and weaving and thinking about clothes and textiles, the issue of kind of ethics and morality come in. So I've been thinking a lot about that as part of when we measure information from our bodies, right? So right now, we're willing to give away all this information on our phones, right? But we can kind of put down the phone, even though Google's probably still monitoring us somehow. But if it becomes part of our bodies and we basically become desensitized to what is being measured and when, we have to think a little bit about what that means in terms of privacy, in terms of even how we share that information. So I don't know if that's something that this group is interested in talking about, but at least in the world of neural lace and understanding human-machine interaction based on brain and physiology, it's a very important area that I think we're all starting to talk about. Thanks very much.
Okay, thank you, Len. Before we open the floor to audience questions, I just wanted to give an opportunity for our speakers maybe to ask each other questions if they have anything that they would like to ask each other. If not, we can go directly to audience questions. So start lining up if you'd like to ask a question, please. Thank you.
Is this on? Yeah. I just want to respond to Paul's last point about essentially privacy of data. And it's certainly something that when you join the military, you give up that privacy. So we don't really have that issue. We still have to worry about human testing, so IRBs, those kinds of things, when we're doing human subject testing. It's actually more controlled within DoD, I think, than it is when I'm doing a university-based IRB. But for human subject testing in the fire service, we ran it through a university to do it. Now, we thought that when we went to the fire service that your average firefighter would not want to have his data collected. Quite the opposite. The average firefighter doesn't want to die. And so they saw this as a health and safety issue. I'm since working on another project, which is more materials development about cancer rates in the fire service. So they've got some serious health issues in the fire service, death rates from heart problems, and then cancer rates. So they are willing to give that up if we can save them and save their colleagues.
Are there any questions from the audience?
I have a kind of a small question. DARPA has been funding a lot of different projects on campus in the lab that we're in. We're looking at ultrasound and stimulating different sites in the body. And I'm wondering, we've been talking a lot today about different concepts of technologies once we expand beyond what we think of as innovation and really expanding that definition. And I'm wondering if we can do the same with the body, and how you think that there's potential to incorporate different concepts of the body in body technology. For instance, a lot of my work focuses on medical theory and especially mapping the body in different knowledge systems. So for instance, in meridian maps in forms of Chinese medicine and also forms of Tibetan and Ayurveda, there are sites that are sensitive at different times of the day, and that are also, in some cases, dangerous if they are stimulated at certain times of the day, depending on the individual. And there's also sites on the hands as well, like the hands and around the pelvis. And as at the back, not so much. There aren't as many danger sites, but there's some sites that can give information about how to approach different physiological states. So I'm just wondering, have you considered these types of collaborations to expand knowledge about the body with specialists who work in different knowledge systems, and how do you see the potential of facilitating these types of collaborations? Thanks.
So, very good question. I think that there are a couple of programs that are fairly recent. One is by NIH called SPARC, and the other one is Electrics by DARPA. And the idea is that there's this whole new area of medicine called Bioelectronic Medicine. And the idea there is, instead, you can focus on the peripheral nervous system as a way to potentially measure and treat elements of the body, including different types of diseases. And the interesting thing about it is it's kind of a validation in my mind for Chinese medicine and acupuncture. And the idea, there are a couple of major pharmaceutical companies focusing on that, but as exactly like you said, inserting within the body small transducers or receivers at specific targeted points and these targeted points are definitely aligned with meridians and I think so the way a lot of this in my mind always tends to work is there's this great idea, and then the devil is in the details, right? So I think that both in terms of using this type of approach to study treatment of disease will yield actually also new ways to understand how parts of the body interact with the brain. So there'll be some kind of feedback there. Like you said, how is it that knowledge is potentially embodied in different parts of our peripheral systems?
Hello. First, I would like to say that I think it's scary how much knowledge Google has about us and how much they control us. Yeah, if we do a research, it's only what Google gives us. So if Google is not working, we really are lost. And then I have to say something to Barbara. On the ships, what about thinking not only having ladders, but slides? And I say this because I myself have a patent on a nanofiber. I also have a background in biochemistry, not only in high fashion. And I don't know if you know about the artificial Geckos setae. I'm sure you know. No? They are self-cleaning and they are produced at the University of Massachusetts in Amherst. So they were working all over the world, but I think Amherst is currently the best. And so actually I think the Navy or the military is working with them already. And they are self-cleaning and they can actually climb up everything. So just having a robot, having this kind of feet and let them do the work what people should not do, I think that's a good alternative.
Right. I mean, I'm not in charge of the ship design.
No,
we're actually working for the Disruptive Technologies Lab at Naval Undersea Warfare Center. So they're the ones that think about the ship of the future. And so they're the ones who came to us and said, well, we tried it and it didn't work, so now we want to try human-ship interface. And actually the problem they've given us is a very small-scale problem. It's not the 6,000 people on the ship. They realized that maybe they shouldn't go that far. We're actually working on a little underwater vehicle communicating physiology from the wearer to the vehicle, which is harder because we've got to go through water as well. So there isn't a thing that they're doing that doesn't have an alternative solution. I think they're always thinking about what's the best solution, and they always have this budget issue as well. So.
Yeah, but you don't have direct contact. I know that something is working also underwater, but you have the water just in between, like maybe a huge amount of water.
Mm-hmm.
Okay.
Right.
And then I would like to know also.
Sorry, just in the interest of time, if we could just have 2 more questions, and maybe in the conversation, the break just after this, we could continue the discussion.
Okay.
I'm sorry to rush you. We're just
very
if you have a quick point, yeah. Go ahead.
If you printed it on the fabric, how often can it be washable?
We have not found printing inks, conductive printing inks that we think are highly durable yet. There are some that look promising, but they're not highly durable, and you have to protect them with something else, so you're adding another layer. Every time you add something to a textile, you're stiffening it and making it less wearable. So our goal is to put it inside the textile as much as we can.
Great, thanks. Just 2 more questions. And then thanks.
Yeah, so first I just wanted to say thank you for all your hard work and forward thinking. In some ways, this seems to me like chainmail technology, if you can imagine a more medieval term, where you're applying a certain protective equipment and then gaining information from it. I was wondering if it's possible you could talk about how our communities would change as a result of this situation. And to be clear, for example, like nursing homes, like this wearable technology could be put on a nursing home person, no longer has to be in a facility, but that facility can now be called home. So that's just an example I was thinking about, and if you could just comment from where you've been and what you see the future that lays ahead for us. Thank you very much.
So yeah, no, I think that that's a clear application from this is ways in which to monitor and help actually provide additional freedom and quality of life for individuals. In my mind, there's always, any technology has good and bad, right? So so I think the issue will be that how much monitoring are we willing to have, and how much monitoring do we even know what we're willing to give up, right? So I think that that's still, getting back to Google, and I mean, the amount of information that most of us give up is way beyond what we actually realize or what we're giving up. So, but I agree. I mean, there's ways in which it's going to change how we interact, how we communicate in good ways and in some bad ways, just like how social networks and Facebook and have done both.
Great. Just 1 more question, and then we'll be done with the session.
Hi. To start off, thank you for the presentation. I'm the sister of somebody who works at a neuroscience lab at Rutgers, Newark, and she's done all sorts of testing with all of these different pieces of equipment. Oftentimes, I've been her pilot subject. But one of the things that I've noticed, at least, is that when you're wearing all of these different kinds of technology, like, for example, the EEG that you had before, it almost seems like wearing it, because it's not necessarily something that you're used to, affects it. Like, for example, there was one time where I was hooked up to something while I was sleeping, and it was a night where the results showed that I had no sign of REM sleep, because it was this sense of being uncomfortable. So I know that it was talked about briefly about the improvements of making this more integrated into the fabric itself, but are there ways in which the technology can be integrated in a way where it feels more natural when you're obtaining the results in the first place?
Well, I think from the work that we're doing, for the worker, it's not going to have user acceptance unless it has exactly what you're talking about, that it is completely transparent to you when you put it on in the morning. It just becomes part of your uniform. It's a hard goal to achieve. The firefighter shirt, we've gone through several iterations, and now it's tolerable by most wearers for their 24-hour shift, including sleeping in it. And we've collected data, and we don't see any difference in sleep. But there's always improvements, and that's the technology bit that we're working on, is trying to do that. Until we get there, until the industry gets there, I don't see this going out of the research lab or out of the training institute into everyday wear, for example, on the connected worker.
Just one last thought there. Just remember that when Apple came out with no keys on a phone, people thought that was crazy. How could you type on something like that? So never, if what is provided has value and it's beyond the tipping point, then people will adapt naturally. So I don't think we're there yet. I think there's a lot more to do, but I wouldn't be surprised that if there's value to it at some point, we just forget about it, and it's part of what we are.
Great, thank you very much. We'll reconvene in 20 minutes for the next session, but please join me in thanking our speakers one more time.
Thanks. That's great. Yes, I am too.